for startups. And so a little bit about OpenCell to start with, who we are. We're a group of scientists, designers and technologists, all really passionate about reducing the barriers for biotech. So this idea sort of started in West London, behind a market, as all fun things do, and it was in 70. Out for science startups, which is so they can have access to all of this shared equipment and have all the benefits associated with expensive equipment in laboratory spaces, but for a fraction of the price. So these are some of the companies that have come through. We've had since 2018 more than 100 plus companies, and that goes from like cosmetics to diagnostics, therapeutics, tissue culture. So we've got a company called Better Dairy. They're trying to produce dairy products from a laboratory, and so they've moved into their own place now, and they're doing very well. But essentially, when COVID hit, we knew we had an opportunity with these laboratories and shipping containers to do something really special in terms of diagnostics, and so we began to create diagnostics labs. And so they were high throughput and open source, which was amazing. They're also, a great disguise. If you're an evil mastermind, there's no way that you're going to be found out that there's a laboratory in a shipping container. But yeah, they were sort of born out of this need for COVID laboratories, and they could sort of be taken anywhere you want. And I was literally, so this is how I came to be at OpenCell. And I worked on the island of Jersey, which is a channel island between the UK and France. And I worked in a car park in 2 shipping containers for all of 2 months, which was really entertaining and learned a lot. But what was really what made this possible was all the collaboration. So the fact that you had 20 plus contributors on GitHub, all focused on the back-end software where it could detect human error. So say you double the potentials that we hope to tap into with our next project and laboratory management systems. So without further ado, I introduce to you the Bio Hotel. So the idea is that every facet of a life scientist's life is going to be sort of taken care of. And so that comes from shared equipment, you've got customizable laboratory space, and it's flexible, modular, and fully integrated. So you'd be able to effectively scale with your business to have an amount of laboratory space that's necessary, which is fantastic. And so this laboratory system, this laboratory management system is the true essential sort of software backend that's going to make these laboratories easy to use and effectively like a life scientist's dream. So we've all come across the issues in a laboratory. I'm not sure how many people have a raise of hands, how many people have worked in a laboratory here, how many are scientist backgrounds. So there we go, quite a few. So there are some certain pains that you get when you have tests and protocols that don't go right. And so I've got a meme that I'm not gonna lie, I stole from the internet, apologies. But you waste your money, time, and sort of energy on all of these different protocols. Like say, for instance, doing a PCR test, you want to know that the reagents are kept at the right temperature for the entire time, and sort of prevent all of these things all of these variables that could potentially go wrong, and have those controlled so that you reduce the amount of errors. And so that's an essential part of the laboratory management system. It's controlling and monitoring all of these background pieces of equipment and uploading that to the cloud so that you can very quickly see if there's anything wrong with your equipment. And then also it will create this amazing audit trail, and it will be time stamped. And so one thing that I think could be really interestingly integrated into LabDAO, say if they want to delegate a specific task to a laboratory, you'd be able to just have this constant flow of data and know when exactly the samples were, say, taken out of the fridge, when the tests were conducted, say with like motion sensors within your fume hood, and then have all of that background data sent up to the cloud along with all the essential active data as well associated to the tests, which I think is an interesting sort of full view of all the data that you could potentially get out of a laboratory. And you could basically just make sort of these reproducibility errors a thing of the past. So yes, and so this is a little look at this laboratory management system as it sort of is at the moment. And so you can see here that there's sort of fridge, freezers, all of these background sort of monitoring systems, as well as there may be some active ones as well. So for instance, you want to know an autoclave has sufficiently gone up to the correct temperature and all of that sort of stuff. So marketing want to call it Alfred, and for those of you that missed the introduction, that's my name. And so I'm a bit concerned about this. They want to call it that because it's going to be like Alfred and Batman, it's the Batman of laboratories. But I'm really worried that I'm going to become the Alexa of laboratories, so hoping that doesn't happen and we can think about another name. But yeah, plan protocols, book equipment, and just record all conditions possible is sort of the future in the way that we see laboratories going. So that's what I'm excited about, and hoping that I'm getting some of that across to you guys, that we need to sort of create a more data-rich laboratory where you can extract all sorts of different nodes of data from it. And so our proof of concept right now is temperature. So this is a temperature sensor that we've created, and you can get all the parts, which is a temperature sensor, waterproof temperature sensor. You have a resistor that I've very neatly put inside some heat shrink wrap wire tubing, and a battery along with a circuit board. And that is literally, I think it comes to a maximum of like 15 pounds, and then you have the foundations for creating a sensor that if we manage to get the open source sort of GitHub up and working and functional, you could connect this to this cloud and be able to have a functional sensor within a laboratory for no more than 15 pounds. And so when you compare that to the traditional gated communities, it's going to be, I think, revolutionize the amount of data that you can get out for a specific price. So this is basically the idea. I've actually got one here as well, so you can see it in real life. It's a little bit fiddly, and it's without its casing. I've got some casings over there, but this is the idea, and it's as simple as this, and it's 15 pounds. So what's that? Probably like $17 off an open source website, and it's super easy to access. So why have we gone for temperature? Temperature is it's sort of, if you put your effort into 20%, you can get 80% out. It is essential for so many different parts of the laboratory. So I've just rattled through a few, but fridge, freezer, minus 80, autoclave, all of these different components, you'd be able to extract useful information out of them. And so if we can deep dive into this and understand all the benefits of getting ambient temperature out, background temperature out, and also actively monitoring temperature, there's so much to do with it. And so this brings us to what we're trying to do with it now. This is our proof of concept and some complicated engineering mathematics. So we've got an amazing, my amazing colleague Javiera has done some complicated modeling and mathematics to basically track what happens to temperature sensors when say things go wrong, things go awry. And so this right here is when an incubator has a power cut, and you can see that through modeling, you can basically see immediately how that sort of, within 5 minutes, I think, you can see the direction that it's going and get an alert back, and then have all your samples saved from sort of effectively not like your protocol being ruined. So that's our proof of concept right there. And imagine if not only for temperature you could do this, but with pressure, light, gas, motion, sound, conductivity. There are so many open source sort of small electrical engineer components that are super cheap out there. And if you could just tap into every single different part of a laboratory, you'd be able to extract so much data out of it that could really give a life scientist's life a much easier time and just reduce variabilities in general. So this is a meme that I actually did make. And so, yeah, as I was saying earlier, currently you're just locked into all of these subscriptions with gated IoTs, which you're unable to sort of, without a massive fee, you're unable to access these APIs and upload them to the cloud. And what we're hoping to do, not only with the biohotel, but also with any laboratory that wants it, we can send them out all the necessary sort of software backend stuff via an open source GitHub and have people not only using them but contributing as well and suggesting new ideas so that this can be developed in a far greater way amongst a sort of a wide-ranging inquisitive community of people that just want to extract more information out of a general laboratory, which I think is the objective of today. And so this is where it comes to this sort of workshop that I've integrated into this, which is how can wet lab data be optimized? And so we, as I've just said, need two key partnerships to be forged, and that is early adopters and contributors. And so we basically just want to create a breeding ground for collaboration. And so I have some sensors with me here, and I'll sort of say if we could get onto some tables, if everyone's okay with that. And then I've got some personas, so I'm basically going to put you guys in the shoes of these sort of startups and the processes that they'll be going through within this laboratory and sort of see what kind of protocols we can make better and improve through implementing different sensors. So I'll have to apologize for my graphic design. I actually created these made up logos. But here's a little bit of information on each one. It's a bit wordy, but up here we've got testing novel antibiotics. We've also got some next-gen algal polymer biopolymers being created, and some testing drug therapeutics and gastrobiome, which are sequencing gut microbiome and proteomics. So these are the teams. Obviously, don't feel like you're sort of locked into these. You could come up with your own life science idea that maybe even goes into a startup after this. But the objectives will be to find one data source, a problem associated to that data source, and a fix as well. So without further ado, I'd say jump into groups of maybe 3 per table, and have a little bit of a discussion regarding what sort of data problems you think could be fixed within the laboratory.
So the data source that we chose, don't know if you can do this, it wasn't on the list, but it's pH levels in the water. And the process was the bioalgae production. So we figured as you grow the algae, it will respire and probably change the pH. So we'll need a way, that's the problem, that the pH changes over time. The fix is to account for that and create an algorithm that doesn't constantly set off the alarm, so that the scientists can stay at home with their loved ones.
Fantastic. Great.
So we came up with a use case for a temperature sensor which will be inside a capsule right next to a nanopore sequencing device, which are already super small, so probably within a couple of years you will be able to fit them into a small pill. Those two you will swallow, and it will go through your body, sequence your gut microbiome, spatially resolved through your small intestine, your colon, and at the same time monitor the temperature, and we'll use that as a proxy for your immune response. And from the data set that we generate from that, we're going to try to establish a link between changes in the gut microbiome and certain infections that you might get.
Hello, yeah, we're the gut biome. I think that's the company with gut biome. And we're looking at the homogenizer in this particular case, making sure that we don't we don't want to over-homogenize our samples, we also don't want to under-homogenize them either. So a data source there could potentially be the time that you're homogenizing for. So the problem being kind of a fixed time, source being a homogenizer, and the fix to be having kind of like a set time period that once it kind of hits that, then it kind of automatically switches off, just in case you're out having your lunch and you forget about it, which happens.
Great. Thank you very much. So, because of time, I'm going to basically briefly go over why DeSci and OpenCell would very much have a good partnership and work together. So, there's data output. Currently, data output in laboratories, as I'm sort of trying to get across, is just not optimized at all. And so, I think we can enrich this environment with metadata, as you guys have all proved in these few minutes, which is amazing. And then obviously there's no gatekeeping as well to do with DeSci, and so in OpenCell we're wanting open access for everything, and so that will be sort of in the form of tutorials and GitHub sort of pages so that people are allowed to innovate themselves, and then hopefully that will create more of a citizen science DIY biology movement, which I think could very easily be successfully incorporated into DeSci, because that, I think, needs to sort of be emphasized. And yeah, unlocking data silos as well. So thank you very much, everyone, for listening. We are currently hiring, we're looking for software engineers that are going to contribute to our GitHubs and try and create these open source sort of databases, and we're also looking for collaborators as well, whether it's early adopters if you're working in a laboratory, or people that want to contribute to the GitHub and create this data-enriched environment filled with open source sensors. But yeah, thank you very much for listening.
Hi everyone, my name is Landrain. I'm from Paris, France, and I think I'm going to speak a bit further from the microphone. A few words about myself before I start this talk. It's kind of funny to be here at the DeSci.Berlin because everything seems to be very new. But I have the feeling I've been somehow doing DeSci for the last 12 years. And through different protocols and Web3. And what I love, however, is the beautiful energy that this group has and reminds me of the early ages of biohacking. My track record is that I started as a synbio researcher in France, and from there I got frustrated from not being able to work with non-researchers, not being able to work on projects that were not part of the topic of my institute. And so I said, let's build another laboratory, a biotech lab where I can do whatever I want and work with whoever I want. And that became the first biohacker space in France and one of the very first ones in the world. And that sparked automatically a community approach to science, where a lot of different people came together, joined that lab, and that experience by itself completely changed my life. Like this experience of having so much fun, working with so many different people, just being able to take whatever initiative that you want to take. You don't have to ask for permission. It just made me realize that science doesn't have to be done using the academic rules necessarily. So for me, from that point on, the mission arrived, and it's like I want to explore that path of what we could call community-driven science innovation. And so I started first with extending this biohacker space from the squat where we were living at the time to a big space in the center of Paris. And that became for me an experiment where I could really test new ways of, new protocols, new processes, new kind of programs to make different kind of people work together. But ultimately what I realized that even though we need open laboratories, for enjoying them you need to be physically present. What about connecting this network of laboratories? Or how about enabling people who are not in big cities, or just, who will not find the right collaborators or the right project locally, but elsewhere? How do we connect all these people and ideas? And so, for me, that's how the idea of building a decentralized laboratory online came to be, and we call it Just One Giant Lab. You will see why we have given this name. And usually I start with say that welcome to the age of communities. The age of internet has enabled us to create communities at a new scale. Communities are not new, it's been around since humans are around. It's a natural way for us to get organized, to get associated. But so far we've been, before the internet, mostly associating ourselves with our neighbors. But doesn't mean that our neighbors are the best person for us to collaborate with, to build projects. That's why universities, campuses, have been built. It's basically a place where talents and resources can be put together. But now that we have internet, this doesn't actually is necessary anymore. And so one thing that we're trying to solve first is the accessibility issue, where on one hand you have a lot of different people that are looking at trying to solve something, and they don't know where to start. They don't necessarily have the right people on hand, like the right collaborators with the right skills, with the right resources. It takes time to ask permission, to get access to funding, etc. It could take up to 1 year, if not 2 years sometimes, to go from the idea to the project. On the other hand, you have a lot of people who just want to be able to contribute, to a beautiful idea, a beautiful dynamic, but they don't necessarily want to lead a project. And so the idea is that how do you bring all these people together so that they create this beautiful critical mass where finally they are able actually to act on the problem they wanted to solve. And so this can happen thanks to the internet. And so we've built a platform that we launched 3 years ago that is basically doing this at first. And so Just One Giant Lab is not a typical platform in the sense that we are non-profit. We didn't want to create another startup with another platform. There are already plenty of them. We see JOGL more as a common. We think that is evolving. Also, all the values being created on the platform is completely reintroduced into the project. And so it's a very long-term vision because it's at the end, we don't see ourselves as an organization trying to compete with startups or academic laboratories. At first, we see more like creating a space that is additional, complementary to what already exists. For example, enabling the exploration of problems that are sub-explored, that are not being sexy to academics, or there is no business model yet for companies. Or just enabling a network of researchers or amateurs, to gather and add all their resources together so that they are able actually to do projects that would be at the same level of what they would get from normal grants. So it's all about building critical mass and giving freedom to act. So JOGL, since its inception 3 years ago, has grown quite massively, and especially thanks to COVID. Right now, it's a community that has more than 7,000 members from all over the world. It's quite impressive to see, how massively it has grown and how the diversity of people that we have on the platform. It's highly interdisciplinary. We have people ranging from people doing biology, medicine, to engineering, a lot of coding, obviously, data science, but also design and art and management. So basically, you can really go on the platform and get to meet people who could help you. Everybody is there with the same spirit, is that they want to help out, right? So the global mission on JOGL is really about to build commons, like to build open source knowledge, open source solutions, and help each other. And so you can trust that if someone is on the platform, it's because they care also about that. So you can contact them basically. So the way we approach things is, as I was saying before, is we want to build a common. So the whole platform is open source from the get-go, and it's completely free, and it will remain free forever for users. And I'll tell you more about our business model later on. But the idea is really to build a digital infrastructure that can help communities thrive. So any kind of community, small, large, and I'll explain how. And so yeah, it's really about also empowering individuals, and you will see how, again, it's, you know, most of the time, especially in science innovation, you are going to trust people that have already received legitimacy, a title, you know, trust from other people. So you have this trust network. But then there is an issue that, what about newcomers, newbies, like unknown people, especially people who are not part of the academic system, who are not living in Occidental countries? How are you going actually to bring them in? How are you going to trust them? So it's very important actually to build an inclusive framework that can enable anyone really, as long as they're motivated and have good ideas and they're capable, to be able to contribute. So one way of doing this is also, it's by bringing, so one thing of the platform does, beyond just connecting people and connecting people to projects, is enabling you to build your community on the platform. And the vision here is, as you build a community, you're able actually to also collect information, you know, about your members and the project, and know what's going on, how you can help them, but also you can collect resources. You can basically crowdfund your own community and decide what to do with all these resources in a way that you will see is very transparent and it's not top down. So one thing we had to design is what we call community review, and that enables a group of assets to be allocated in a very open and fair way. So we have many communities being on the platform right now. We just launched a new feature that is called Spaces. And the idea is this also enables a group of people who would normally have built their own platform because they wanted to scale things up to not do it because it's very expensive, and to maintain the platform is very hard as well. So we do it for them. And another also very important aspect of JOGL is we have this, what we call social infrastructure around it. So, to build a community, to maintain a community, to sustain a community, you cannot just use a platform. You have humans, you need to interact with them. You need to animate that community. You need to engage your members. And so we have designed different kind of processes. We can also help you, if you're interested in putting in place good processes, good practices in place. And really at the end, our point is, how do you make science and innovation more inclusive, obviously, more efficient, and you'll see how, more fun and more impactful. And our engine, our core engine is what we call Giant Labs. So it's a new format where instead of trying to put everything around names, like big PIs, like trying to play on egos and reputation, we try to put the problem at the center. And then you have members, people, organizations that come together, and they bring with them expertise, assets, funding, facilities, like laboratories, with all the same idea of being able to share these as a support mechanism to the ideas that will be defended or to the project that will be provided by the community. And so how is this support mechanism provided is through an evaluation mechanism that we call community review. And it's a continuous evaluation process where that is very open, very inclusive. I'm going to explain how it works right after this. But what it means is, to get access to this pool of resources, your project needs to be validated by the community first. So what that means is, you can be a nobody. If you join the community, have a good idea, and it matches the problem that the community is working on, you can get access right away, actually, to a lot of support that is going to make your project advance extremely fast. And it's very agile. The way community evaluation works is, first, you want things to be extremely simple, extremely scalable, because a community can be extremely large, and very robust, because you want to be able to trust the system. So the way it works is, a project is going to first create an application based on a template, and then the community is going to evaluate that proposal. But in order to make that evaluation robust, we need at least 4 to 5 evaluators per project. And in order to make it scalable, we want a lot of reviewers. How do you find reviewers? You know, it's actually one of the main bottlenecks of the review systems. So what we have implemented is that in order for your project to be eligible to get access to funding or resources, you as an applicant needs to be a reviewer as well. So you need to review at least 4 to 5 projects that have applied. This has many implications. It means that you are never going to lack reviewers because the ratio between project and reviewers stays the same, even if you have 10 projects or 1,000. Also, it means that members of the community, the applicants, the project leaders, will know about each other. We know what other projects are doing. So that will encourage as well collaboration, even convergence, and sometimes merging, and we have examples of that. So it's really enabled a change of rules where it's not about who comes first, it's really about how can we create also the best project possible together. So that's really important. The other thing is because this is very fast, so this is a process that takes only a few weeks. From the moment you get, you deposit your application, your proposal, to the moment you receive funding, it's maximum 2 months. Usually it's about a month and a half. So extremely fast. And the way we implement things is every 3 months we have a new round of evaluation. So for example, if your project didn't make it, it's okay. You can actually learn from the feedback of the reviewers, try again 3 months later. If your project makes it, but you fail somehow, that's okay. The community only lost that much, but at least you could try. So it's a way actually to take risk because the cost, of betting on a project is actually very low. But if your project works pretty well, then you can present your results, get asked to be evaluated again, and get money again. And this as much as you want. So it's a very agile mechanism of support where you evolve, like the community supports you as your project evolves. And this way, you don't have actually to make a big bet on one project only and see what happens. You can make many bets on many projects and basically train them and learn with them as they grow. Here is an example that it's one of the major programs that we created on JOGL around COVID and some of the results that got out of this program. Open COVID-19 was launched in early 2020 and the end of February 2020 and was the only place on the internet where people that wanted to do science and open source hardware, for example, or software, could gather in order to help the pandemic, fighting the pandemic. And we successfully raised some money through foundations and public institutions, and we could provide about 120,000 euros to the project that were validated by the community. 36 projects were selected by the community in 5 rounds in more than a year. Out of those 36 projects, we got more than 20 functional solutions, actually 12 papers published in peer-reviewed journals. When you think about that, in terms of yield, it's incredible. It's much higher than what you would normally find in normal academia or even actually in the startup world. Another thing is the diversity. Almost half of the project funded were led by women. And also the diversity in terms of countries and origin were extremely high. In fact, it's not 4 continents, but 5 if you count the 2 Americas as 2 continents. And so we were really amazed by the level of diversity, of collaboration. A lot of people didn't know each other when they started collaborating with each other. The level also of collaboration between projects. There was a lot of merging as well. And that was very encouraging. And you can see here some of the projects that were done. It ranged from medical devices to diagnostic tests to prevention, like mask or education projects, social science, basic research. It was extremely large. And projects were done as much by researchers than students or professionals, amateurs. Even one project was selected and it was done by high schoolers. So it's very interesting mechanism that enables anyone in the world that is interested by one problem to join forces, get support from others that also are passionate about that problem, and at the end try build actually a project that works. Just as a matter of reflection, some of the diagnosis tests that were designed actually were the first one to be open source for COVID in the world. And 3 of them got in the semi-final of the X Prize, which is an international innovation competition where like major startups and companies around the world participate. Even one of them got into the final. Just to show you that even though those projects were community driven and actually really in terms of comparison underfunded, they were as successful as major companies' projects. So it's in that way. These are some kind of numbers, but about 30 projects pass community peer review, so it's quite stringent. But 80% of the community-vetted projects actually were successful, so it's very high. And you could even say that the JOGL approach enables innovation at 1/10 of the cost of traditional R&D. So it's a very interesting approach in that sense, that we now are trying to apply to different domains and to provide also to different communities around the world. It could be existing communities, formal communities done by foundations or public institution laboratories, but also it could be just be informal network, of like for example biohacker or researchers or just professionals working on a given problem. Yeah. So it's here's a team. We have some ambassadors. If you're interested in joining the community, please do, and some of our partners so far. And yeah, I'd love actually to see some of you on the platform. Create a profile, have a look to the project, maybe even actually invite some of your friends, put some of your projects. Maybe if you work in research laboratories, convince your research lab to even actually bring some of their project there, and start the dynamic. One of the key roadblocks for making all this happen is the change of culture. Like as long as people didn't experience this, they don't think actually it's possible. The ones they've done it, they don't want to come back. So it's really about bringing more people and giving them the taste of this approach. I think I'll finish here, and thank you very much.